Welcome to the second set of 3.8. Remember we were talking about using inverse matrices and we're going to solve linear systems. We looked at when we had a matrix equation, but now let's look at a regular one. If you remember way back when we started chapter 3, we looked at graphing and finding where the lines crossed, and that was the solution. We looked at elimination and getting the point where they crossed. We looked at substitution. The other day, 3.7, we used Cramer's rule to solve it, and now this is your fifth method for solving. One that the book doesn't make a big deal out of it, but I think it's pretty cool. So, the first thing you do is you take your system and you write down all the coefficients. So what's with this x? 4. What's with this y? A 1. What's with this one? A 3. And what's with this term? A 5. Then it's pretty slick. You do just this little xy matrix, and if you look at this, if you multiplied, you'd get 4x plus 1y. Oh yeah, that's what we have. And so we set it equal to the solution matrix, which is 10 and negative 1. Okay? So, everything's going well. We got it set up. Now, if you remember the other day, what we talked about is multiplying by the inverse, and then you get rid of it. So what you do to one side, you do to the other. So all we need to do is find the inverse and multiply it by our B matrix. So, first of all, to find the inverse of our A, remember, first you've got to do the determinant. So 4 times 5 and 3 times 1, and you subtract between those. And so you get 1 over 20 minus 3. Well, what is 20 minus 3? 17. Okay? And then don't forget, when you do this inverse stuff, you have to move some stuff around. These guys get to swap places, 5, 4. And then these guys stay where they're at, but they change their sign. This one's positive, so it becomes negative. This one's positive, so it becomes negative. And now all we need to do is multiply. Well, 1/17 times 5, and some of you might think, oh, that's a horrible fraction. It's going to be fine, I promise. Negative 1/17, negative 3/17, and then you get 4/17. So this is our inverse matrix. And since you were amazing in the first part of 3.8, this isn't so bad. So now we take that, and we've got 5/17 and negative 1/17 and negative 3/17 and 4/17. And we're going to multiply it by this one. And let's kind of review matrix multiplication just a little more. Remember, this is a 2 by 2. And how many rows does this have? 2 and 1 column. So we know our answer is just going to be a 2 by 1. I have no idea what this one is about, I'm sorry. Okay, so this is first row, first column. So here's our first row and our first column. Okay, so 5/17 times 10, and then negative 1/17 times negative 1. Let's see, that's 50/17, and this becomes a positive 1/17, which is 51/17. And you think, seriously? But that just reduces to 3. If you do the second row, first column, you've got negative 3/17 times 10. You've got 4/17 times a negative 1. This gives you negative 30/17. Gives you negative 4/17. We're going to add them. And once again, you go, oh, seriously, Mrs. Roth, negative 34/17? This one, that's just negative 2. So you found out x is 3. Remember, we had x is 3, and y equals negative 2. You didn't have to graph anything. You didn't have to get the same coefficients. Pretty sweet. All right, let's move on. We'll do one more example. Hopefully this doesn't cause you, on that freeze here, doesn't cause you any trouble either. Okay? All right, so this one, we're going to actually have some minuses in. Remember, make your coefficient matrix That's pretty easy. 3, -1, -4 and 2. Then we just have x times y, or x and y I should say, probably not x times y. And then our solution matrix, which is 5 and 8. Okay? Now, remember this is our A, and we want to find the inverse of A. So we're going to do our determinant, 3 times 2, and -4 times -1. And you do subtract between those. So let's see, 3 times 2 is 6. -4 times -1 is 4. Oh, 6 minus 4, that's not bad. That's just 1/2. Yeah, see, it's not always 17. Okay, now we got to mix the numbers up, remember. These two get to switch places, so 2 and 3. These you're going to take opposites, so what's the opposite of -1? It's 1. What's the opposite of -4? It's 4. And now we're going to do that easy multiplying. So half of 2 is just 1. Half of 1 is 1/2. Half of 4 is 2. And half of 3 is 3/2. Okay? And this is your inverse. And we're almost done. Okay, so next we take that inverse. And we're going to do that 2 by 2. And we're going to multiply it by the solution matrix, which, what's its size? Oh yeah, 2 by 1. And that tells us, well, there goes my paper, but it's fine, that our answer is going to be a 2 by 1. So we've got this one and this one. This is a part of first row, first column. And this address would be second row, first column. So circle up my rows, circle my column, okay? First row, first column. So we've got 1 times 5, and we've got 1/2 times 8. And when you add those up, you get 5 plus 4. Well, that wasn't too bad. That was 9. Sorry, I'm back. Were you worried about me? Except, did I mess up a sign or something? Okay, and then you do 2 times 5, and you do 3/2 times 8. Okay, I'm going to let you work on that for a minute. Oh, you know what? I think I wrote this down wrong. I'm sorry, you guys. This is a -5, -5. -5. So let's change a few things. -5. So what is -5 plus 4? -1. We get a -10 plus 24/2. Oh, good heavens. Oh, wait. That's just 12. And so you get a 2. And your answer is -1 and 2. And you probably just saw how important it is not to skip a sign. Because, oh, that could have caused problems. I kind of knew what it was supposed to turn out to. I thought 9 is not it. Okay, so we know that these two lines would cross at -1, 2. We know if we plug these in, it works in both equations. Okay, little shortcut for solving systems. See you later.